All right, so welcome to Software Bill of Materials the hard way. We're going to talk about hacking Bob the Minion, and this is sort of a redo of my DEF CON presentation from this year at DEF CON 32, which didn't maybe get as much time as it deserved. So let's get to it. Let's take a look here. But first, my name is Larry Pesce, and I am the Product Security Research and Analysis Director and the Services Team Lead here at Finite State. Um, I was making the joke for a while that when I came to work for Finite State that I was getting out of penetration testing to do some other stuff, but I'm back doing penetration testing, and it's been a whole lot of fun coming and doing some penetration testing as well as all of my other duties here at Finite State on the research and product analysis side. Um, penetration tester, services team lead, do all sorts of other sort of fun research here at Finite State. Some of my other activities include co-hosting and founding the Paul's Security Weekly podcast. We are currently in our 19th year. Very soon, it seems like, to move into our 20th year. Paul and I have been doing that podcast longer than some of our children have been alive, as well as longer than some of our marriages. So we've been sort of inseparable pair for many years and having lots of fun doing security news and technical segments and all the other fun stuff. I'm also a student at SANS with a bunch of certifications, but I am also a principal instructor and course author. The courses are specifically around wireless security for SEC 617 and for Internet of Things pen testing with SEC 556. Now, I like to include something fun in my intro, and that I claim that I'm a recent convert to the Oxford comma. But I've had that there for a little bit of time, so maybe it's no longer a recent convert to the Oxford comma. So the newer fun one is that I very much enjoy long walks on the beach, weighed down my ham radio for the preparing for the impending zombie apocalypse. Uh, so yeah, I do some ham radio stuff, arguably not as much as I would like, but I'm working to free up some time to make some of that stuff happen with some more regularity. All right, so we're talking about Bob the Minion here, and we're going to do some hacking for Bob the Minion. And you may have noticed on the title slide that there was some depiction of some of his minions and so forth. And I am a huge fan of AI generated art. So this is one of the very few slides in this presentation that does not feature any AI generated art. But I would be remiss if I didn't take with the theme for hacking Bob the Minion and use AI to turn myself into an evil, despicable me villain for hacking the Bob the Minion router. So here we are. Here is me as the despicable me villain, and will arguably be the one that is going through this exercise with hacking Bob the Minion. All right, let's get to it. All right, so in the beginning, we were talking about some SBOMs, and well, so lots of little baby minions to generate some SBOMs from, right? What goes into this? Well, as part of my work at Finite State, we arguably we do lots of things for supply chain security, from shifting left to shifting right, and helping you secure your supply chain security as at time of development and all of your commits to being able to analyze that final binary. Securing your stuff and being able to give you some really accurate software bill of materials. And that's why sort of I had this focus on trying to get a software bill of materials for Bob. And we'll talk about Bob in a little bit here. But arguably, we're going to see the inevitability of software bill of materials, especially when we start talking about some of the regulations and initiatives here in the United States, specifically focused on Executive Order 14208. For being able to sell into the federal government and other locations requiring a software bill of materials as part of your offering. Also with FDA's 524B, potentially requiring some software bill of materials and arguably a software bill of materials as an essential part of any of the FDA submissions for new products to go to market, as well as the FCC's new cyber trust mark, sort of a UL or protection program, so that when you are buying consumer items from the store, there is a security rating to go along with that. And as part of that cyber trust mark program, software bill of materials are kind of essential to building those programs. Also, this is not just a US based thing and or why we're going to see lots of software bill of materials. We also have one of the major regulations, the Cyber Resiliency Act, or the CRA, in the European Union, in which, to sum that all up, any device, electronic device, IoT, that type of stuff that you are purchasing that runs software in the EU is required to have a software bill of materials associated with it. So these software bill of materials aren't going to go away. And I kind of like this, and not just because of the fact that I work for a company that produces software bill of materials, but those software bill of materials for the consumer and for the manufacturer, in my opinion, have lots of benefits. One, gives us a software inventory of all the components of software that goes into that. Specifically, when we think about manufacturers who are not completing everything that goes into their software on their own, they're using software from a third party. From one of their upstream suppliers. They are maybe using open source software and then developing some of their own stuff on top of that. So being able to generate software bill of materials for the entirety of that binary that is going into the final product can give you an overall view of what's in it very accurately. And then taking that data and performing some enrichment. So based on all of these items that are in the software bill of materials, uh, what libraries are there, what components are there, what versions, and are there vulnerabilities associated with that are public, CVEs, and so forth. And arguably, those CVEs tying into additional enrichment through threat intelligence. And that was the subject, arguably, of my RSA talk this year, specifically software bill of materials for evil. The gist of that talk was take all of that enrichment data, um, from an SBOM, enrich it, get your CVEs, tie that to threat intelligence, get proof of concept code, so that I know that there's a potential device in an environment that, as a penetration tester or as an adversary, I could test. Before even having to send a single packet, I had all sorts of reconnaissance. And ultimately, what we want folks to do is to do that same methodology in their environments before they're releasing software so they have the opportunity to resolve issues before it goes to market. All right, so software bill of materials, they're not going anywhere, and we're going to see a lot of them. So I maybe have a vested interest in getting software bill of materials and analyzing code and firmware to verify accuracy, to find some fun stuff, to validate that the portions that we are detecting via CPE match can then match to our CVEs and so forth. So it helps make our product better. Arguably, I think it's all sorts of fun to start doing the analysis on these devices and find places where we need to add some stuff and to verify that all of these new discovered vulnerabilities are being found in the products that we're analyzing. Okay. So part of some of the role of my team, myself and my team, is for us to see new devices that are coming out into various marketplaces, get new firmware and or new versions of that firmware, perform some extraction and reverse engineering, whether that be manually or automated through the Finite State platform, to do a lot of that correlation and find lots of known stuff, and potentially we every once in a while, more often than not, get to perform various levels of hackery with the devices, find all sorts of unique and surprises, and potentially even find some opportunities for new vulnerabilities within some of the stuff that we're analyzing. And this is something that has been near and dear to my heart for nearly 2 decades. When Paul and I put together a book on hacking some IoT devices, and it is really amazing that now I get to do this full time for a living. So, as part of my day job and as part of attempting to save the world one IoT device at a time, I really, really, really love software bill of materials. All right. So as part of our journey, suddenly a wild Bob appears. A wild Bob, you ask? Where does Bob the Minion enter into software bill of materials? Well, I encountered this very interesting Wi-Fi router intended for the consumer market. Specifically, the model is the DevoloLink AX1800. AKA Bob the Minion. And this is a product, if I remember correctly, licensed from DevoloLink by Universal to be able to take a nice, arguably, Wi-Fi router and put it in this fancy case that is Bob the Minion themed with a web interface that is also Minions themed as well. So it was kind of like a tie-in to all of the movies and that type of stuff. And you get this nice, cute Wi-Fi router. Unfortunately, this Bob is missing all of his insides, but the case is like this is Bob the Minion. Um, the Bob the Minion router is a Wi-Fi 6 router with 802.1ax and some mesh support, and supporting some of the newest Wi-Fi security with WPA3. And quite honestly, it is billed as having some pretty interesting hardware. When I think back to some of my earlier days in doing some Wi-Fi router hacking and so forth, this device has 128 megs of flash and 256 megs of RAM. Like we were used to dealing with 8 megs of flash and 4 gigs of RAM. So in my opinion, this device has tons of possible capabilities by orders of magnitude from arguably some of the earlier days. And my earlier days were definitely focused around OpenWRT or OpenWrt, but unfortunately, there is no current support for OpenWrt for these devices. But I have seen that there's been some discussion to try to make that happen. Okay. Bob is about $70 shipped with Amazon Prime, so also relatively reasonably affordable. There is a Kevin variety. Kevin is a little bit taller of the minions and has hair. So Kevin features some updates to Bob, specifically around adding Wi-Fi 6E, so in the 6 gigahertz range, but they're almost double the price at about $130. Now, knowing that this was potentially a device that I was going to have to do some interaction with and not sure how this was going to go, I opted for the cheaper version for this one. All right, so let's talk about the firmware. So arguably, I'm starting to populate an SBOM and generate an SBOM by having the binary, the final output of that firmware. But I struggled a little bit obtaining firmware for Bob the Minion. So firmware, what firmware? Well, I went to DevoloLink's support pages and so forth to see if I could download a copy of the firmware from DevoloLink's website, and there is no firmware for the AX1800 whatsoever within that, and I suspect I'll be invaded by a cat here. So one of the cats is wandering around, but that's okay. So no ability to just go to the website and download the firmware, which made step number one that a challenge. When you fire up one of Bob the Minion routers, you go into the web interface, and as part of the administration console, you click the check for updates button. there were no updates available, meaning the firmware that was on the device was the most up to date when I purchased it and removed it from the box from Amazon. So this also means that I can't now go capture the transfer of the firmware from DevoloLink to the Bob the Minions router when I click check the updates because there's nothing to transfer. So I can't download it from the website. I can't capture it off of the wire, as it were, with the network packet capture. So my next thought was, well, what happens when someone manages to do something bad to one of these routers and bricks it, and they can't get access to it? So they have to find a method for updating the firmware, some other method by USB or TFTP or some other method. So I went to the support forums to see if, hey, I can't get access to my router. I need to reflash the firmware. How do I do so? And I couldn't find anybody asking those questions, nor could I find anybody offering download links for the firmware for that process. And to make it even more difficult, DevoloLink is a Korean company. They had two different versions of their support forums, one in English and one in Korean, which Google Translate helped me find some stuff for those Korean versions, but nobody offering. So, unfortunately, with no ready access to the firmware, what that really means was there was going to be no SBOM. Okay, so Bob the Minion running around in the really dirty wasteland with no software bill of materials. And for me, as part of my job, with no SBOM, that means no fun. And quite honestly, being chased by a pack of wild dogs, admittedly maybe a little cartoony ones, is doesn't sound like a whole lot of fun to me. This one was a really interesting to prompt to Midjourney for because I wanted Bob the Minion being chased by a pack of wild rabid dogs, and no matter what I did, it always ended up being sort of really bright and happy and cartoony. No matter how many times I asked for a post-apocalyptic wasteland and gritty and dark, it always gave me something with like full sunshine and grass. So here we are. Here we are. All right, but so no S-bombs means no fun. But you know what is real fun? Brain surgery. Brain surgery is a whole lot of fun. And this image comes courtesy um, of again Midjourney, and specifically, I think about brain surgery in sort of a humorous context and a sci-fi context. Specifically, the Adventures of Buckaroo Banzai Across the Eighth Dimension, which was a really campy sci-fi film from the 80s. And I'm a product of the 1980s, early 1990s film culture. So this is crazy sci-fi film. It's really fun. In the Guardian's top 1,000 list of films that you should see before you die, and in Entertainment Weekly's top 50 sci-fi films. So if you haven't seen this, you're missing out. Great stars like Peter Weller, John Lithgow, Jeff Goldblum, Christopher Lloyd, Ellen Barkin. Great stuff here. So effectively, what I asked for here was Buckaroo Banzai, portrayed by Peter Weller, performing brain surgery on Bob the Minion. And what I got was this horrific mashup of Peter Weller and Bob the Minion. So here we are. So it's apparently got Peter Weller's ears and Bob the Minion and some external brain stuff here. I don't know, but there's a great line from the movie when Peter Weller, who's not only a time traveler or interdimensional time traveler, is also a musician, rock musician, and a brain surgeon. And he's performing brain surgeon, and one of the other doctors goes to do something, and he says, "Stop! Don't touch that. You don't know what's connected to." So we don't know what Bob's brain is connected to here. But let's go find out what Bob's brain is connected to. All right, so no downloads means we've got to go get firmware the hardware. Specifically, we had to go disassemble one of these nice little Bob the Minion routers, and well, he's got no more insides. So no more insides to Bob. So yeah, we've got some of those pieces of insides, sort of right here, and we had to do all sorts of very interesting things to that. So first up, take the board out, start looking at all the various components on those boards to see what chipsets are available and how we can potentially start interacting with this board in an attempt to recover firmware. One of the chips was the RTL 8198D, arguably some system on a chip, processor, Wi-Fi chipsets, and all sorts of other stuff. Examined the board for opportunities for interacting with a serial console, and there was one, but didn't give us a whole lot of access. So, especially in recovery of firmware, maybe we can boot to a bootloader and use the bootloader to dump copies of the firmware for us, but didn't have a lot of luck there. So now, arguably, we've got to go about it the really hard way. Maybe we need to interact directly with the processor over the Joint Test Action Group interface, the JTAG interface to dump firmware that way. Or maybe there were some opportunities for us to interact with SPI flash. And I was kind of hoping that the flash was not built into the RTL 8189D. And fortunately, I was in luck that the SPI flash for storage of the firmware of the operating system image was in fact stored on a WinBond W25N01GV. Which, when you go to Google and search for the data sets and the specification sheets, tell us right off the gate that it is a 3-volt serial SLC NAND flash memory with dual quad SPI. But even more confusing was that it is a 1 gigabit SPI flash, and yet DevoloLink bills it as 128 megs of flash, when it in fact from the manufacturer says that the specification sheets are 1 gig. That's a whole lot more storage. Again, orders of magnitude based on what they say versus what is actually available. So there's an SPI flash here. Maybe going about this the SPI flash way is a heck of a lot easier than JTAG, and trust me, it is. So let's go about grabbing SPI flash interfaces in an attempt to interact with the WinBond W25N01 GV. To recover the running operating system image, or more importantly, you take the device from the box, never turn it on, and attempt to recover the default firmware flash, much as like if we would actually downloaded a copy from DevoloLink's website. So that became a process. And again, like I said, every one of these slides does have some AI generated art. And it is arguably a portrayal of me going through this process of recovering firmware from this WinBond SPI flash chip. So this is arguably what society thinks that I do when I go about trying to grab something via SPI for those flash chips. And this comes from an article from one of the labs at Intel Corporation, featured in Wired. So thank you for the picture. And this is them using some really great some setups and all sorts of oscilloscopes and great microscopes with cameras, and like this is what is portrayed in the media about folks that do hardware hacking. So this is what society thinks I do. And well, I don't have that kind of lab, so arguably this is what my friends think I do by taking the board out and throwing it into my PC bytes with these the PC bytes curved interfaces with this big mess of wires everywhere. In an attempt to read the chip while it is still in situ on the board, and right at the focus of our DediProg pointer connections. So my friends that are in the industry, this is they have a little bit better understanding. This is what they think I do. All right. And this is what I think I do, and this is typically how it works out. And we'll talk about some of the issues here. Is that more often than not, I am soldering wires directly onto the chip, onto the board, as opposed to using the DediProg, and sorry, not the DediProg, the PC bytes. And I was seeming to have a whole lot of issues with the PC bytes, whether it was not making accurate connections and so forth. And arguably, I think I traced it down to some other failures here, but I struggled for a long time trying to get a read on one of these chips. And in fact, I thought I had some pretty good happening here with the stuff that I think I do. But unfortunately, I actually feel like I met the magic smoke out of one of these boards. So this was also not successful. So this is what I think I do, but this is really what ended up happening. Is I ended up taking one of these boards and having to do chip off analysis. So removing the SPI flash chip with a hot air rework soldering iron in an appropriate environment. And then using one of these off-board adapters to take them to pin headers and DuPont wires. I didn't actually have one of these. I had to go buy one, and fortunately, they were only a couple of dollars from Amazon, and had them delivered in just a day or two from Amazon Prime. Uh, so had to do this whole chip off with this adapter and then attaching them via the GPIO pins onto a Raspberry Pi to interact with it directly, as opposed to using a whole host of other tools here. So just take the DevoloLink board out of the PC Bytes nice standoff and throw the Raspberry Pi in there to have a nice place to hold it with the chip dangling around with all these wires. So arguably, it got crazier and crazier, and less elegant and less elegant as I went through this process, with all of the struggles related to the trying to recover firmware from these SPI flash chips. All right, so this is what I really did, and definitely had some issues with getting reads with the PC bytes, but I think this ultimately turned into some issues with some flash ROM support, which we'll discuss. Okay. The one that I soldered, I apparently let the magic smoke out, and it no longer functioned. The boot status lights, when you booted it up, with or without those cables installed, wasn't the same anymore, and I could never access it over the network and so forth. So unfortunately, what that meant was that I broke the first one, and I had to go buy more of them, and I bought two more, figuring I might break yet another one here, which now we went from a $70 project to a $210 project. But I mean, that's okay. Arguably, I got a great trip out of this to DEF CON to go present, and have lots of great content out of it. Anyway, so arguably, no big deal on that. But I'm glad I wasn't doing this with Kevin at $130 a pop. I'm glad I used the cheap version. So some of the issues that I started with while using the PC bytes and then moving over to those soldered cables, which ultimately led me to break the first one, was attempting to use the bus pirate to dump this SPI flash. Specifically, in both the Bus Pirate 3.6 and the 5, um, apparently that neither of these two devices have enough onboard memory. They only have 128 meg to be able to dump the flash onto the device and then write it to disk on the connected system. And I thought I was going to be okay because this had always been advertised from DevoloLink as only having 128 megabits of flash, when in fact the flash chip based on the spec sheets is 1 gig. So not enough memory to perform those operations on the 3.6 and the Bus Pirate 5. I know the Bus Pirate 6 is out now, and I just got mine within the last couple of weeks. But I don't think we're going to have much difference with the Bus Pirate 6. Also, there's been a pretty significant change between the Bus Pirate 3.6 and the 5 for platform support and the way the connecting of cables go. And there's arguably some competing documentation to what's shown on the device and what the actual documentation for the Bus Pirate 5 is, because it is still really, really new. So there's lots of confusion about how to connect some of the stuff, which may have also led to me applying power to wrong pins on the chip with the solder on board and potentially with the PC bytes, which leading to my ultimate failure here on that particular device. I checked out a bunch of other tools as well, and some of them weren't so good. One that I did potentially encounter as part of the research to figure this out was a tool that supports directly WinBond at the factories where the WinBond chips are being utilized by manufacturers to program and read these chips. Um, but it was several $1,000s for this particular piece of hardware. They also didn't say that they supported the N01 version of this chip. They supported the N02 version, which is effectively two N01s stacked on top of each other, and that's not what I had. So I couldn't confirm with ordering this $2,000 device roughly that it was actually even going to work for the situation. Um, Supposedly, the FT 2322 as a serial UART device had the potential for interacting with the SPI. I did not have one of those inexpensive ones on hand, and I also did not have a DediProg, which is also relatively expensive, in the $350 to $900 range. So I didn't have one of those. But the other options was the Raspberry Pi and Flash ROM, which is the route that I eventually went down. Unfortunately, the version of Flash ROM, the official version of Flash ROM, didn't support the chipset. No one had written the parameters for it, so there was no chip detection there. Also, the default version of Flash ROM from the Flash ROM creators has no support for NAND flash. So, all right, what's next? So one of the next options was potentially to do generic SPI or reads and writes using SPI bit banging. Specifically, I came across a website, Magirius.com, and where the author said he was able to do flash dumping on the WinBond W2501GV, which is a similar chipset to ours, using SPI bit banging with a script. And I tried the script over and over and over again, and lots of troubleshooting. And again, the documentation wasn't terribly great there. And I I could not get this to work. I could get it to dump a 1 gig file full of all zeros, which was not terribly useful. So I had to find some other ways to do this. Okay. Well, what really ended up happening was to use the cheap adapter, the chip off board onto that cheap adapter connected to the Raspberry Pi, which required I really destroy one of these routers by taking the chip off. Now, absolutely, they can go back with some degree of success if you're very patient. Uh, I was also able to find a fork of Flash ROM where someone had added NAND support from Froloff WFW7. NAND support there. That version of Flash ROM did not have support for that individual WinBond chipset. But I found that there was an alleged unmerged commit in the main tree to support that. So I found that data out there in the Git repos and so forth that supported it, which I find weird that if Flash ROM doesn't support NAND, why did someone add support for this chipset? So I added the chipset support to the default Flash ROM and couldn't get it to read. I was using the PC bytes and the soldered version and still couldn't get flash ROM on the Raspberry Pi to work. But when I moved to the one that had NAND support and then manually patched the one with NAND support with the support for this chipset, I got some success. Like I was able to dump with the Raspberry Pi and flash ROM the total 1 gig contents of this flash chip to disk. So finally, we're 40 minutes into this webcast, and I finally got firmware, right? So there were lots of moving parts here. All right, so now that I've got firmware, we can get some treasure, right? And in my opinion, that first bit of treasure is that software bill of materials. The prompt here was for Bob as Indiana Jones recovering treasure from the temple, and that's kind of what we got here. So, arguably, I cheated. No, I didn't cheat. I used all of the resources available to me, and that's what hacking is all about, right? So I was able to leverage that firmware through the finite state platform to do the analysis of all of the various components, and take that components via CPE matches to CVEs, and then those CVEs to some threat intelligence. So we found just over 2,600 findings of all varieties, high, medium, low, critical. Found a bunch of interesting opportunities for some potential 0 days based on code analysis, some issues with some of the configuration, and tying some of those findings to threat intelligence. We're able to note that there was, 380 potential proof of concepts code out there. There's some reported in the wild, exploited by threat actors, and even 16 of them that had valid code for us to potentially weaponize against this device. This is the firmware that came off the device before being powered on as purchased through Amazon with arguably no updates available. All right, so what else did we find? So looking at that threat intelligence from our SBOM, there was a lot here. And in the case of being able to determine capabilities and some threats here, we take the CVSS score and temper that with exploit reachability and so forth with EPSS. So, and sometimes that will go up, and sometimes those scores will go down, depending. But we found 70 so we found a whole bunch of issues with 79 various status vulnerabilities with exploits available, whether that was proof of concept, weaponized, and so forth, all within the critical to high areas, and even some mediums that were pretty bad as well. And this is without counting anything related to the Linux kernel. So the 79 issues of critical to medium that had some attack code associated with it doesn't reflect any of the issues that we discovered with kernel stuff. All right, so great. We've got some of that, but now what about some of the other things that we discovered on the firmware? So not only was there treasure, but there was also some spoils. And in this case, poor Bob having to eat moldy bread here. So he's got the spoiled bread. And what did we find in those spoils? Well, the first one was some potential credential problems here. Through all the documentation, there is one documented user, specifically the Bob user, and we kind of would have expected admin to be here, but okay. We found that they were in the Etsy password that they referred to as password.ori in the DevoloLink firmware. There were 3 valid users, and I took nobody out of this list here. 3 valid users, 2 of them were not included in any documentation that I could find. And again, in this default firmware from the device, never been powered on before, the user of Bob had a password of Bob. Yeah, all lowercase Bob, 3-character password, all lowercase. Now, based on actual consumption of the device, I actually have one powered on here and have logged into the web interface. The Bob user updates that password on first boot. using some sort of math to generate a password based on something known about the device, um, to print that password on the sticker, on the label on the device as well. Okay, but we had these two other users, and I sent the output of the hashes to some friends with some really good password cracking rigs so that they could leverage Hashcat against them. And Hashcat exhausted all of the possible combinations that they threw at this, and I didn't bug them too much because they were doing this to me as a favor. Um, but it is possible that exhausting the entire US character set, that there may be some Korean used as part of this password storage. And I'm not positive, but it is a possibility given that we were not able to crack those passwords using the traditional US ASCII character set. So more to come on this when we can get some more resources to throw at that. All right, so not only did we find credentials, on this default firmware, we found some other interesting stuff, such as some private RSA private keys and some certificates, potentially for web interfaces, once we were able to pull apart that firmware. Now, this becomes kind of concerning is if we think about what we need to do for any of our certificate stuff for the web server and or any authentication to potentially network services with SSH and so forth, that all you really need to be able to authenticate to some of these devices is the public certificate. And the private certificate should be secret. Now, in this case, we have the private certificate and the private keys for TLS and for SSH. The question really becomes, this is default firmware from the box, and it's never been powered on, so no opportunity to generate these at first power on. This particular dump of firmware has never been on a device that had power on. So are these the same on every device after boot? Unfortunately, I ran out of time before I could actually test this stuff. But if it's the same on every one, and we can capture these, we may now have the ability to authenticate to every router that has services available connected to the internet if appropriate services are enabled, and or capture traffic to the web-based interfaces and decrypt that effectively to become machine in the middle. So it's kind of terrifying that some of these certificates end up on the device in the default firmware and potentially never regenerated on first boot. Okay. All right. We also discovered that traditionally I'd go and look at all the web pages and the web interfaces and look at all the CGI bin scripts to see if there were opportunities for local file includes, command injection, authentication bypass, and all of those types of things. But what we did discover was that the web interface was written entirely in JavaScript for the client front end, including a JavaScript CAPTCHA when you guessed passwords too many times incorrectly. And the CAPTCHA was all implemented on the client side. And we all kind of know that if you send that to the client, you can start manipulating that client data on the untrusted client to potentially get around those types of things. We also discovered that there was arguably a custom web server with integrated functionality for decoding all of the JavaScript and so forth in some features kind of like BusyBox with a single monolithic application. We didn't have enough time to do analysis of this custom web server. It just needs potentially some better emulation and so forth, or access to a running device. Okay. Doing some analysis of some of that JavaScript, there was a potential here in the password reset function once you were authenticated to the device for some possible command injection because there were some passes to some Linux command line utilities, specifically BusyBox, to change password, leveraging just whatever variables that were potentially unsanitized from the user. So maybe we could pass command injection as the password to change it to on these devices. All right, found a couple of other fun stuff, maybe a little bit less impactful. But as pouring through a bunch of the other contents here, we found a bunch of scripts to help support the device and as part of the use of the device. And in pouring through some of those scripts, we found a bunch of IP addresses and URLs that were pointing to addresses at LG's U Plus services, some end hosts at Korea Telecom and Chunghwa Telecom. There was also a script that piqued my interest a little bit that was entitled Snapshot, and it performed some uploads to some of these IP addresses, and I don't remember whether it was LGU Plus, Korea Telecom, or Chunghwa Telecom, to some of those end hosts. Turns out the script for Snapshot wasn't like a full upload of everything. It was some very select sort of configuration files, and ones that I noted didn't contain sort of end user data like passwords for Wi-Fi and so forth. Okay. Also, if you noted when we looked at that password.ori that one of the users had a default shell of bin dvsh, and we kind of surmise that that is not bin or any other normal shell. It was a custom shell written by DevoloLink, DV for DevoloLink shell. And as best as we could tell, it looked like it was an Ash clone. For what reason, we have no idea. But maybe there's been some changes there, and maybe requires a little bit more investigation, a lot deeper than we have been able to currently undertake. I found that the kernel was running 44140, which is not new by any stretch of the imagination, but arguably pretty bleeding edge for what we are seeing in consumer IoT. So kind of not a lot of surprises there. All right, some things for me to do, and potentially even some calls to the community. I'd love to see OpenWrt support for Bob here, so that we could get rid of all of those questionable practices and leverage some new supported stuff and turn it into all sorts of other fun stuff. I suspect that the hardest part of that whole thing, especially given the size of Flash, is going to be support for the Wi-Fi chipset, and how the Wi-Fi chipset manufacturers support some of their open source stuff. I'd love to be able to take this firmware that we've dumped and send this through some emulation, so we can work on some of this without requiring Bob the Minion's hardware. Um, whether that be through Firmidine, Firmware Analysis Toolkit, FAT, QEMU, or even FirmAE to make that happen. We're going to use the right tool for the right job here. The other one that I thought would be very much on brand for Bob the Minion would be to perform a brain transplant. I've got the router. I've got that first one that I bricked that let the magic smoke out. And I was also able to obtain a bunch of blank, unused, brand new from DigiKey, WinBond W25 N01 GV flash chips, completely unused, brand new. And I have a dump of the flash, and I have new flash chips. So why not go and write the flash to the new ones? And we ended up with some issues around unsupported writes for that. Also, as things develop, we're going to be doing some more ongoing reporting to DevoloLink for some of the security issues that we've been finding, to see if maybe they can do some stuff and improve. All right, but breaking news. Some of the things that, as we started moving forward about that brain surgery, um, I spent a week struggling really hard trying to write the image that I had acquired from one to the WinBond W25 N01 GV using that forked flash ROM with the added NAND support, but they only did the fork for NAND read. No write possible. And the only way Flash ROM was going to work for me there was to actually go and write the code to support all of those write operations. And quite honestly, that Not going to happen. I don't have that level of skill set. That's not where my skill set lies. But I found this other tool called flash underscore W25N, which claims to be able to write in flash ROM style to the flash chip connected to a Raspberry Pi, arguably in the same pinout that used for the flash ROM utility. Um, but I was never actually able to confirm that I was able to get a successful write. It leverages the older wiring Pi libraries, which have been deprecated. So I had to do a bunch of interesting stuff to the Raspberry Pi to make it work. Now, I say I never got a successful write or read because what I ended up doing was taking Flash W25N to flash it and then use it to read it back, the same tool to read it back. So I probably should have tried to use Flash ROM to dump a second copy of that and see if there were any differences, and that maybe one of those directions was broken with the Flash W25N utility. Maybe it was doing a successful write to the blank chip and me just not being able to tell. But arguably I did, I ended up spending the money. I did go and get, the DediProg to be able, and the DediProg definitely supports the read and write. I just need to get a few more hours in the day to make some of that happen. Now, that is arguably a fairly large spend. It was able to go into the $350 range instead of the closer to the 900 stuff because they really didn't need all of the extra stuff. But still, it's a good chunk of change to be able to do some of this hackery. That said, to wrap us up, um, thinking about some of the problems that we had, if there's no firmware for a device that, yeah, absolutely, we can get there. And as a result of getting that firmware, if there's no software bill of materials, we can get there too with appropriate tooling. That was some of the argument that I received about my talk at RSA about software bill of materials for evil. Well, then let's just not give software bill of materials to anyone. Well, that becomes a little bit of a logical fallacy, right? If I can't get a software bill of materials, I can't get a software bill of materials, then no one can determine what products are in my device. Well, if you can buy a device, you can potentially recover that firmware to generate a software bill of materials, to map it to all of that threat intelligence, and so forth. So if you can buy it, you could allegedly get it, and that was very much the illustrative process for this webinar. Was that if we can acquire a device, we can use some hardware hackery to recover those system images to ultimately generate that software bill of material. And performing that enrichments will help us find our treasure and our spoils. Some of the other things that we did see that, yeah, some of the newer consumer IoT devices are starting to see some modern things that they're doing, modern being relatively speaking on the kernel side, some processes using stuff like JavaScript for the web interface, something arguably non-traditional, and also some really new hardware, especially around some of these flash chips and some of the wireless chipsets as well. Okay. Also, one of the big things that came out of this is for folks that are looking to perform this type of analysis in their environment, the open source tools are very much lacking behind some of the commercial stuff, and I kind of get it. Open source being supported by the community and so forth, as opposed to having lots of commercial resources behind them. And like free and open source flash ROM, free and open source some of these other SPI bitbang type of tools and you name it, didn't have support for a lot of the stuff and still are lacking on some of the support for NAND stuff. Also, it's kind of no surprise based on some of the other research that we did with Forescout on some OT routers, which was kind of not a surprise based on some of the Forescout research, the Forescout finite state research, that the IoT security and software supply chain is still troublesome at best, especially given that we found 74 potential horrible issues with this router and no updates are available. And this is something that was released within the last 6 to 8 months. So I'm really hoping that when we bring this full circle, when we start talking about some of these regulations, both US, EU, and Asia Pacific, that we're going to start seeing the requirements for software bill of materials that hopefully the manufacturers and consumers can leverage to start making this whole process better, and that we're going to see fewer and fewer issues with some of these devices. So I can hope, and that's kind of really what I want to see happen here. Let's use this stuff to make our environments better. All right, well, that is it, and we're about 1 minute. So again, if there are any other questions and so forth, please don't hesitate to write those in, and we'll get those answers. So big thank you to all of you for showing up, and if you've got further questions, feel free to reach out at a later date. I know some folks don't want to ask in a group setting and so forth, and that's perfectly fine. I get it. Okay. But I would also be very remiss if I didn't say a huge thank you to my coworker Edwin Shuttleworth, who came in clutch and doing some of the analysis of the firmware. And in homage to his to thank you to him, he has also been rendered as a Despicable Me villain. So thanks, Edwin, and thanks to all of the team at Finite State for supporting me. And I hope you all had fun, learned something today. And if you have questions, please don't hesitate to follow up and enjoy the recording for those of you who did. All right, so with that, we'll wrap us up. And thanks, everybody, and we'll see you soon, and stay safe out there.